Hey Raj, how's it going?
Hey Luca, good. How about you?
You need to hear this one. I was with a customer, and when I was in Berlin, I was with this customer and was telling me, "Oh yeah, look, one of the hardest thing that they have found is not, let's say, implementing and using AWS services, but understanding which service should be used when, and basically mapping my intention when I want to express certain architectural patterns into AWS." And I found extremely interesting this question because it's not something that we spend too much time often writing down or publishing here and there. But I think is a very important topic in general when you think about the software development lifecycle for mapping the ideas and what you want to express into tools that basically is the AWS ecosystem. So, what do you think about that?
Oh, I love this topic. But this goes back to how architects think, and architects don't see just black and white. We see many dimensions. Yeah, let's dive deep on this topic, like
Hmm.
how you work backwards from the customer, and then we don't make it easy. We give you a lot of options how you can choose certain tools. And I have some stuff that I'm preparing for a customer meeting. Do you want me to share my screen
Yeah,
and go through it?
why not?
Like as an architect, when you look at a big application and it's like scary, it's like a big giant thing. The way I approach it, and I use this to architect many different projects, is break it into logical blocks. So let me give an example. Let's say one chunk is consumption, as in how will customers consume information from your system. So in a three-tier architecture, which is a very, very popular architecture, you could think of the users coming to your website. Next is the processing part, where you are processing the user input and you are executing some business logic. The next block is storage, as in how will your data be stored. And the final block is ingestion, as in how will some data be ingested or fed into the system. And I'll give an actual example in a couple slides.
Yeah, go for it.
Once you have these blocks, then you can think of your non-functional requirements on how to make each of these blocks perhaps more secure, plug in observability, more scalable, optimize cost, etc. So this actually is derived from first order principle thinking, where it says that you break down a big problem into the smallest
Yeah.
chunks that you can solve. So think about Lego blocks instead of one big solution. And I found it helpful both for interviews and real world projects.
Yeah, makes sense. You know what? The one thing that triggers me every time when I hear the word non-functional requirements, because for me, more it has like this negative idea, non-functional requirement. I always think about what about architecture characteristics that, in my opinion, represent very well. Because after defining what you described at the beginning, the business problem, when we talk about architecture characteristics, it seems a very positive thing. Like, okay, so we apply architecture characteristics into business needs and requirements, so that will basically create the foundation for then say, okay, so this is our context, and from there we start to move into the implementation phase. What do you think?
Yes, sometimes names get stuck like non-functional requirements. The same way we say soft skills are very important. To me, soft skills are not soft skills; they're like hard skills. To be a good architect, soft skills are very, very critical as the hard skills. Because if you create a great architecture, but if you cannot convince or influence folks to adopt it, then it's kind of no use.
I totally agree with you on this one because I usually call them core skills because because in reality, if you think about that, as an architect, and that's something I was used to say also to my team, 70% of your time you need to create empathy, you need to be capable to communicate a different level of the ladder, from the developers to the C-suite potentially, and even let's say external companies or whatever. And you need to tweak your language, but being technical enough to understand everything that is happening and what's the impact of a tiny thing that a company decide across the entire organization and development lifecycle.
No, 100%. And maybe in our young years, we think that we are going to create the perfect architecture. But now, at least I am old enough to realize that there is no perfect architecture. Every architecture has pros and cons. And so that's why you cannot rely on just the technical parts to for your architecture to stand out, right? You have to have the ability to navigate the disadvantages, take into account the customer nuances, etc. And I think some of that will become clear as we go through both of our architectures. Okay, so if I go forward, so if I take this example where I divided the big scary architecture into logical blocks, so if I think about how to design a retail website, so the consumption layer will be front end and microservices. The processing layer will be the back end. The storage layer will be the product database where it is storing the information of the product, as well as the transaction database. An ingestion layer is batch loading some information, for example, maybe price of a product or description of a product, real-time product data, etc. Now comes the interesting part. You have to choose AWS services for each of this layer. And we have many different options, right? Both the consumption and processing could be done using our different compute layers such as Kubernetes, EC2, Lambda. You can do the network interfacing in between layers with application load balancer or API gateway. The storage could be NoSQL, such as DynamoDB or Amazon Aurora. And ingestion could be done with something like AWS Step Function. So the question I ask myself is how to select services, and is the design good for these requirements? So you have to keep in mind the functional requirements or the features, non-functional or architecture design factor requirements, and you have to go back to AWS well architected framework as well, because we have 6 pillars, which pillars are more important to the customer, and based on that, you can go forward. So let me give you a couple examples for functional and design requirements. So for retail website, some of the features could be browse product, buy product, product recommendation, and some of the architecture factors or design factors could be it needs to be highly scalable, must be cost efficient, must be secure, right? Because that's where all your payment information is. It should be highly available. Similarly, going forward, I'm going to say one more and then I'm going to move forward. And then parking garage, functional requirement could be show availability, different car sizes, should be able to process payment. Now you'll think, Raj, like shouldn't the design factors be same for every use case? Not really, because parking garage is a good example. It doesn't need to be highly scalable because in each parking garage, there are only finite number of parking spaces. So though the front end needs to be scalable up to a certain point, but the database is not going to be as scalable as the retail website. It should be cost efficient, should be secure, and highly available.
I think you touch a very important point here, Raj, because very often, we tend to apply exactly the same rules for every single workload in a distributed system. But the beauty of distributed system is that we can express different nuances inside our architecture and apply the right level of, I don't know, security, availability, resilience, whatever, and then understand what will be the impact if a service is down without, let's say, affecting maybe the entire system. I think it's a super valid point, this one.
Yeah, thank you. No, I mean, so I get this question a lot that I want to make a secure application, right? I work a lot with public sector.
Yeah.
That itself is a very, very broad requirement because there could be different levels of security. Sure, DDoS, web injection is a starting point, but then do you need to inspect traffic? Do you need compliance? And think of this as like a pros and cons, as in every feature you add, you are sacrificing something. So if you add traffic inspection capabilities, there will be some latency, there will be some cost implication. So as an architect, when you hear these words like, I want my system to be highly scalable, you must dive deep to understand what does it mean. And just to give a quick idea, my question is, so there are two different kinds of scale, right? One is how high should your application be able to sustain a certain amount of traffic? Second is the burst, right? How fast that peak will be there. For example, if you're releasing a new product and there are millions of people waiting for it to buy, then the burst also needs to be super high. And achieving burst could be a little bit more difficult than achieving just a supporting higher number of traffic. You have different knobs to adjust, right? So as an architect, you always have to dive deep a little bit and then put down the design. We are like kids in a candy store, right? We always want to jump to the part where we get the candy and start eating it, as in jump into design. But it's very important to take a step back, understand the requirements deeper, and then do the architecture.
Totally. It's like it's been more or less like few weeks that I'm thinking to write an article with the title "The Lost Art of Designing Software." Because I think very often, as you said, we rush into the conclusion, say, okay, well, I've seen this team or this other team that is doing that, and I would do exactly the same, so I know I would be compliant. But without even taking a step back and understand, do I really need all that complexity, or do I really need all that simplicity? Because the reality is every single workload has his own story and his own requirement, and very often, we always look on one side that probably is the technical one, because maybe we want to try the latest and greatest, or we have a specific thing that we want to try. But the reality is these effort of gathering all the requirements that are technical or not technical are the key point, and investing real time on understanding. Very often, people are rushing on creating the stories in the backlog, so at least they can start to code. But that time is extremely important to understand really what we need to express inside our code, and then will be the flow will be extremely fast and frictionless, because and you have your intentions, let's say, in your head, that are clear, and you don't have to go back every 30 seconds and say, oh yes, why I should do that, why we cannot do it this other way. Because investing that initial time, that doesn't mean designing everything up front, but having enough information in very lean approach and mindset to have just enough to kick off a sprint or a new workload with clarity of intention, for me, is something that very often is forgotten or underestimated.
Yeah, totally agree. And funny thing is, even though we are discussing about this functional and design factor requirements, sometimes there are other things that take over all these things. I'll give a quick example before I move forward. So one time I was designing an architecture, a microservices, a serverless microservice. I know that is very near and dear to your heart. And based on all the requirements, I'm like, okay, API gateway will be great here. But the company had licensing terms with Apigee, right? And they already paid a lot of money. So basically, they said, look, we already have this for 1.5 years licensing terms, so we cannot move right now, right? It doesn't make any sense. So the plan was we modernized the backend from VM to Lambda, but then we left the API layer as is, and then we took a stab at it after like 6 to 8 months. So there are some lot of other factors that sometimes comes up. There could be some teams which support certain components, and if you architect a design which is too far from them, they might get threatened, they might get scared, right? And they will really, really resist. So you have to take all that into account, how important each of these factor. Okay, let me move forward. And for this discussion, let's focus on one use case, which is a retail website. So if we go back to our logical diagram, So for each of these layer, we have all these different AWS services. Now let's assume for this case, the customer is already running the application, but in on-premises, and the existing application team is proficient in managing virtual machines. The operation knows how to patch it, rehydrate it, and basically they just want to move to AWS as fast as possible so that they can shut down their data center and they can start having all the advantages that AWS provides, the scalability, agility, etc. So they choose lift and shift. So in this case, the recommended service will be application load balancer for the traffic interfacing. The code can run on AWS's virtual machines such as EC2, and then they do replatform the database from MySQL to Amazon Aurora MySQL. And I'm ignoring ingestion layer for this video to keep it on time and focusing on the critical layer, which is consumption, processing, and storage. So if we put this together, so the flow will look like this: 3-tier architecture, the presentation layer, the traffic is coming to application load balancer, and then your web server is hosted on this EC2, and then you have another application load balancer sending the traffic to the application layer. The code is running on EC2, and that is going to the database, which is hosted on Amazon Aurora. Users will consume the website using this application load balancer and this EC2. So this is the consumption layer. The processing layer is here. The traffic coming through ALB, getting processed in EC2, and the storage is the Amazon Aurora. Now, if you go back to the non-functional requirements, or as Luca calls it, architectural requirements, what do you have to do to make this design highly available and scalable, right? So since we have a limited time, we cannot go through every factor, but let's think about those two factors which are quite critical. So application load balancer out of the box is already highly available, whereas EC2 is not. So if we talk about high availability, you have to make sure that this EC2 is at least deployed in 2 availability zones. And to make it scalable, we are also introducing auto scaling group. Again, note that we are not putting scalability on elastic load balancers because it scales automatically under the hood. AWS manages it. So the thing I'm trying to show is you need to think for each block and apply the architectural requirements. Now let's say some time have passed and now the team has picked up some expertise on containerization and they want to move to Kubernetes. So the way to think about it is the same way, each logical diagram for each layer and then map it to equivalent Kubernetes components. And let's say you are knowledgeable with EC2s and load balancers and you learned Kubernetes. A good way is to map the new knowledge to your existing knowledge. So that's something I have done when I switched my career from mainframe to AWS. I will think in mainframe the database is DB2 and the equivalent database is Amazon RDS or Amazon Aurora. You get the idea. So this is our system design with EC2 and application load balancer. So when we go to Kubernetes, your applications run in a container which runs inside pods. And these pods can run inside EC2 or in a Fargate. And you scale this using replica set, horizontal pod autoscaler, and cluster autoscaler. I don't want to go too deep on each of these. However, for Kubernetes, keep in mind there is always an open source component and then there is an AWS component, right? So all these icons with the blue background, which looks like hexagon, they are Kubernetes open source component. So let's say, for example, to implement scaling, you need to learn the open source component, which is replica set and horizontal pod autoscaler. And then you need to learn the AWS part, which is cluster autoscaler, or Carpenter, which is the latest and greatest autoscaler for Kubernetes. Similarly, in Kubernetes, the application load balancer can be integrated with ALB ingress. So ingress is again the open source components. And then you integrate the intermediate load balancer with ingress as well. You deploy cluster autoscaler, HPA, replica set to scale the application layer, and there you go. So this is how I think about big system designs. I break it down to smaller chunks. I think about the services that's available for each of those logical block. Depending on the requirement, I select the service, and then I implement non-functional requirements on each of those layers. And then when I modernize that architecture, I think how the modern service components map into the existing architecture, and I go from there.
Yeah, no, I think is very interesting, right? Because you started from understanding what was, let's say, the initial architecture characteristics and the business requirements, and then you started to say, okay, so if you are in this context where you have like you're using virtual machine, maybe you are on premise and you want to mix and match between cloud and premise, you're using EC2, and then that is basically the knob that will trigger the idea of, okay, so I'm in this situation, then use this true. Then you said also, okay, now you can even go in a more abstracted fashion, and you can start to think about, I want to move into AKS world, but AKS can be even with Fargate. So you delegate basically the complexity of auto scaling and the underlying infrastructure of the cluster to AWS. That I think is it resonates very well with me, because it depends from your context of what you're trying to express. But sometimes, the value is let's say even more on what you are writing inside the container, and therefore what is running inside the pod. And there where you can really let's say link what the business wants to what the consumer will have, and therefore generating value for your company.
Yeah, 100%. Well said.
Yeah.
But yeah, I'm curious now, Luca, like how will you approach this and how does your designing process look like?